Good morning to all of you. Myself, Professor N.V. Adpe from S&T College of Engineering and Research Center, Yeola. Now, today we will discuss the working as a assistant professor in S&T College of Engineering and Research Center, Yeola in Electrical Engineering Department. So, today we will discuss the new topic that is to find the solution of linear algebraic and transcendental equation, polynomial equation by using Newton-Raphson method for two variable. So we already studied that in a Newton-Raphson method for a single variable. This is your single variable. In that only one initial guess is present of value of x, that is x1. Then from by using Newton-Raphson method, we can find the next guess which is near to the exact root of the equation. And according to that, to reduce the error and find the exact value of the exact solution of the equation. But in that method, the in a function in Newton-Raphson only one variable. The function is defined by the f of x. Function is defined by f of x. But in uh, that method, the function is defined as f of x comma y. F of x comma y and g of x comma y means in that there are two equations are given. There are two equations are given, and from that two equations we can find the values of x and y. We can find the values of x and y, that is root of find the value of x and y satisfy this equation. So we start this method. Let f x comma x0 comma y0 be the initial approximation of equation of f of x comma y is equal to 0 and g of x comma y is equal to 0 in two variables, that is the function f of xy and function g of xy. Expanding the functions f and g by Taylor's theorem for a function of two variables up to first order derivative, then f of x1 comma y1 is equal to f of x0 plus h comma y0 plus k. Then it is equal to f of x0 comma y0 plus h into d by f by d by x of x comma x0 comma y0 plus k into d by f by d by y for x0 comma y0. Means first taking the function f of x0 comma y0 plus h is a constant into multiply by d by f by d by x, means we can take the partial derivative of function f of x comma y with respect to x and take a value of x and y, that is x0 comma y0 plus k, it is also second constant, into d by f by d by y, means take the partial derivative of function f with respect to y and x is constant, and put the values of x and y, that is x0 comma y0, and for the second function g of x1 comma y1 is equal to g of x0 plus h comma y0 plus k equal to g of x0 comma y0 plus h into d by g, means it is the partial derivative of function g with respect to x, and put the values of x and y as x0 comma y0 plus k into k is your constant, and take a partial derivative of function g with respect to y, with respect to y, and put the values of x and y as a x0 comma x0 and y0, x0 and y0. Let x1 comma y1 be the solution. Let x1 and y comma y1 be the solution. Then f of x1 comma y1 is equal to 0, and g of x1 comma y1 is equal to 0. And how to find the x1 and value of x1 and y1? By using the equations. Substituting in equation 1, we get f of x0 comma y0 plus h into f of fx of x0 comma y0 plus k into fy. Fy means the function, the partial derivative of function with respect to y, with respect to y, and fx means the partial derivative of function f with respect to x. Then put all the values, then equation is f of x0 comma y0 plus h into fx, x0 comma y0 plus k into fy, x0 comma y0 is equal to 0, and g of x0 comma y0 plus k into gy means taking the partial derivative of g, function g with respect to y, of x0 comma y0 plus h into g of x0 comma y0 is equal to 0. Then rearranging that, h into fx x0 comma y0 plus k into f of x0 comma y0 is equal to minus f of x0 comma y0, and h into g of x0 comma y0 plus k into g of y, gy of x0 comma y0 is equal to minus g of x0 comma y0. By solving this equation 2 and 3, we can find the value of h and k. We can find the value of h and k. And now the x1 will be, now the x1 and y1, find out the x1 and value of x1 and y1 by using the formula. X1 is equal to x0 plus h, and y1 is equal to y0 plus k. Give a new approximation to the solution. By repeating this process, accuracy can be improved. Means from this equation, we can find the values of x1 and y1 for the iteration number 1, and again repeat this process. Repeat this process as a repeat this same process as a f of x1 comma y1, f x1 comma y1, and g of x1 comma y1, and repeat again and again, and then as the accuracy is occurred, then we can stop for the iteration. This is your method to find the solution of transcendental and polynomial equation by using Newton-Raphson method for two variables. So in next lecture, we will see the numericals based on the Newton-Raphson method for two variable and regular Falsy method. So stop here.